All right. So,
Right there.
yeah, go ahead and put your take-home section away because we're going to practice. So there's one reaction left that we're going to be doing, and that is the reaction of zinc metal with a solution of hydrogen chloride that we call hydrochloric acid. And hydrogen chloride is an aqueous solution we call hydrochloric acid. And it's going to be a single replacement reaction. Now, if it's going to be a single replacement reaction, let's far forward. Yeah. So again, in a single replacement, whatever is alone kicks out whatever's in a compound, and whatever's in a compound gets kicked out to be alone. Well, zinc is positive or negative? Positive. Always positive. So the zinc is going to kick out the hydrogen, and you're going to be left with a compound of zinc 2 chloride, which is going to be kind of semi-aqueous, and hydrogen gas. So go ahead and take a second to balance this as I prep it.
What? It's just snacks. How did you get that? Free snacks. I don't know. And I have to be there with the teacher. Free snacks. And then I'll be there with my
So all you guys who have no notes out at all have already been doing it. Yeah. So some people in the back row have it done. If you don't have your notes out, take your notes out because we're taking notes today. Did you do it? Yeah. This is a single replacement.
So, on the test, Mr. Myers?
Yes.
It's going to be multiple choice for everything.
Everything but what you have in front of you is multiple choice, yeah. So the take-home section you have in front of you, that is obviously not. Everything else would be 100 multiple choice questions.
Yeah. For this take-home section, if we have balancing on this,
You do, yeah.
it's already on.
It's gonna fill it.
Oh no! My balloon has a hole in it.
Oh no, you need another balloon.
It's too late. I blew the reaction.
Gotta tie it lower than where the.
I guess I'm going to need some help balancing this. I can't balance it from here.
I will balance.
Thank you. Please do. Rise up and balance that thing.
Let me guess.
So dang.
Hydrogen gas.
Rise up, sir.
Isn't that what the reaction tells us is in here?
Yeah.
Yeah.
Come on, thing. Odds make them even. Odds make them even. Come on, thing.
Boom.
Nice.
Is that right?
Yeah.
Yes. Well done.
Nice thing.
Hey, dude, don't break a sweat out there, bro.
This is a very exothermic reaction. This is getting very, very warm. Okay. Now, assuming I don't allow the thing to, assuming it doesn't break, and that would be hugely embarrassing. Then we're going to take the hydrogen gas.
Blow it up.
Yeah. We're going to take the hydrogen gas, which is H2, it's gas, and we're going to react it with the oxygen in the air, which is O2, and that's going to produce water vapor, which is H2O, and that's also going to be a gas. Sorry, it's not super big. I had a leaky. I had a balloon leaky.
Do it again.
It actually fit. All right.
Sorry, it's not that big.
Sorry, it's not that big. I had a leaky. Wait, you children, dirty minds.
dirty mind.
I don't have a great mind. What do you mean?
I have a clear mind.
Okay, so the
Jameson,
hydrogen
you
gas
want-
is escaping as we speak, so we're on the clock here. Thane, you want to blow it up?
Yes.
Here, grab some glasses.
We already did something to do.
Hurry, Faye, hurry.
Hurry, Thane!
Okay, lift hard. Lift hard.
Here you go.
Go, Thane!
That was pretty lit.
Come on, Thane.
That was lit.
Go!
Fire. It was lit.
Bro, you acted like it was a gunshot.
Okay, so yeah, so this one's also pretty easy to balance. Oxygen and hydrogen are diatomic, so they're not just H. Think of it later.
Yes.
Not today. We have a number of names we get through. So H2 and O2, and it's not diatomic, so obviously it doesn't need to be H2O. So we got two O's here. Now we got two O's there, more hydrogens and more hydrogens. So, any questions so far? So those are our 5 reaction types. Synthesis, when things come together to form one thing. Decomposition, when one thing breaks into its parts. Hydrocarbon combustion, which is always fuel, plus O2 makes carbon dioxide and water. Single replacement, when one thing kicks out something. And then double replacement, when they switch partners. Okay. So, if you understand this, and I hope you do, I have some balancing practice. I'm going to take a few minutes and then choose 4 military volunteers to balance the following things. Yes? Double replacement?
Yeah, we did.
Yeah, we did.
With the yellow potassium iodide?
Yeah, we did that.
Okay. Well, check your tubes for a review.
You don't really.
No, I have like
So again, bang these guys out. In a few minutes, I'm going to call in military volunteers to put their work on the board.
No, it has to be FE, right? PS2.
Okay,
What can you put? What number? Run it down, double it out, right?
How do you choose?
3. Yeah, and then it's 6, 5, and then oh, that smells great.
Thank you.
That smells great.
I can't smell
That one. You know how old that is? Yeah, the machine in China. China wanted to do foreign surgery. Not to do it. And they tried on the grape. It's serious. Oh, shoot.
Because you were roasting me
Hey, no cyberbullying.
Is this cyberbullying if you both enjoy it?
No.
Okay, sweet. So it's not cyberbullying.
you were roasting me for that, so I was like, what are these?
Michael, are you using your tool? Your phone as a tool or a toy?
Go and do the hardest one. Go do the double replacement.
I don't know how to do a replacement, but I'll try my best.
Do them all. You can do it.
I can do them all.
You can do it. I believe in you.
Age 10.
Yeah. Regardless of what your parents say, you're going to be a successful young man.
Maybe in grade school, right?
You can do it. I believe in you. Just ignore what Grandpa said.
Grandpa was not being serious that day.
You literally did. Literally did. Literally. Oh, what is CO2? That's
Drake is the GOAT? Actually,
Donut.
You have the double up there.
No, people got right. Oh, I feel like don't eat drugs. Yeah, you did. You know all that teeth. No, we did not. Oh yeah. No, we didn't.
Hey, Sydney, you have the double replacement notes? Wow.
I got 20 blocks. You could beat on check your work.
Gotta make sure everything is. Yeah.
I was right.
Okay, screw it. No, we didn't. No, it was definitely not better.
So I pull Gavin out and put him on top, regardless of who we're how much on top.
Yes.
Yes.
can.
Pull me out and put me on top, please.
I just don't understand those two.
I'd like to
when you
divide.
divide, like the C4H10.
Okay.
I want to do.
But guys, again, you don't have to use this technique, but I strongly recommend it. If you get an even odds or an odd even, double it. So here you got odd even, double it. Even odd, double it. Okay? Even odd, double it. Anytime you have an even odd, double it. You can always reduce later on. It just makes it so much easier when you're not dealing with odd numbers.
Saying what?
It's so.
Yeah. Here, start with the carbon. Start with the carbon here. And go back.
Is that right?
Yes, that's right. Good start for a very first one. The very first exercise started 5 minutes ago.
So we don't have enough carbon.
Yeah, you can always go back and replace. Anytime you have a compound that is both even and odd, it has an even and odd, I recommend you double it to make everything easy. Not required, and you can always go back and reduce. But I find it to be a good starting point.
Weeks ago, don't have. No, actually,
Chloe, you have number 1.
no, that's not. Oh wait.
Cameron, you have number 2.
I have not seen that.
Hey, look at that! Gavin, I didn't even shuffle it in. Gavin, you have number 3.
Okay, sweet. That's what we need.
And Sydney Adams, you have number 4. Yep. Who has it? Or what is it? Oh, Sydney Adams. Oh, Sydney. You heard that you have number 4, right? Okay.
You got it, Cindy. Let's go. Let's go up there and do it.
You can do it. I believe in you. You can do it. Don't let the haters get you down. I wonder why. Oh, there's some sulfur right here.
Oh, I actually got glasses. Me too.
And some right here too. And some right here. This place is ugly with sulfur.
It's just write numbers and
It's because it's so ridiculously hard to clean. It doesn't stick to anything. Or it sticks to everything. Okay, so start with the phosphates. Realize that right up front, you have 2 phosphates here, and you have only 1 phosphate one.
Something like that. I have croissants. You want me to come over here? Well, I already kind of went for almost but if you want me to come over here, but I'm very done with your best. Or
Basically what you have is what number does he keep here? 2 nitrates and compounds.
I'm not cool. I is too. I'm
Each compound has 2 nitrates. How many compounds will we need?
it's a thing.
Okay.
Apparently it's a
Each
spell.
compound.
You know what this is?
We need a total of 6
piece of
nitrates.
curvy plastic.
How many compounds do we need?
It's called the spill knot. They're like making knots spilling.
No, maybe that's like a place where you put your copy and you carry it.
What times 2?
That or it might be like a plastic where you can set stuff on it.
Now we bounce this. 3 magnesium. 3 magnesium. 2 phosphates. 2 phosphates. 6 Okay, take a look, guys. Let's see how we did.
Yep.
4 irons. 2 by 2 is 4 irons. 6 oxygens. 3 by 2 is 6 oxygens. 3 magnesiums. 3 magnesiums. 2 irons. 2 irons. 3 oxygens. 3 oxygens. Look at this one. 8 carbons. 8 carbons. 20 hydrogens. 20 hydrogens. 8 times 2 is 16, 10 times 1 is 10, 16 plus 10 is 26 oxygens. 13 times 2 is 26 oxygens. Goofy, but not all that hard, I mean, once you actually realize it. 3 magnesiums, 3 magnesiums, 2 phosphates, 2 phosphates, 6 silvers, 6 silvers, 6 nitrates, 6 nitrates. How we doing? Good? Ready to move on to new stuff?
Yeah.
Okay, question?
Still trying to write down.
Oh, okay. Still scribbling? Finish your scribbling.
You're gonna like that.
Very cool, Raphael.
Moving on. 10, 9, 8, 7, 6, 5, 4, 3, 2,
Blast off.
Okay. Mole ratios. Really simple idea. When you hear mole ratio, it means the ratio of moles of compounds in a formula. It is simply the coefficients from the balanced chemical equation. That's what the mole ratio is. It's just the coefficients from the balanced chemical equation. Nothing special. Okay? So that's what the mole ratio is. You look at the coefficients, and the coefficients from the balanced chemical equation are the mole ratio. So the mole ratio of the entire reaction here is 1, 1, 2. The ratio of hydrogen to chlorine is 1, 1. The ratio of chlorine to hydrochloric acid, or hydrogen chloride, is 1, 2. The ratio of hydrogen chloride to hydrogen is 2, 1. That's what mole ratio is. Simple, right?
Yeah.
Good. So just write down mole ratio from balanced chemical equation, or mole ratio equals coefficients, or something along those lines. We're going to use mole ratios in January when we do stoichiometry, which is the measurement of stuff. You know, like, how many of this do you have to have of this? That's what I do in my head when I'm putting stuff together. I feel like, okay, I need 3 moles of this, which means I need this many moles, and then I put it together for you. It happens behind the scenes for you. It'll come to the front of the scenes in January. Okay, questions? Give me a thumbs up if you're ready to move on. Moving on. All right. We talked about exothermic and endothermic reactions. In an exothermic reaction, energy goes where? Out. Exothermic means outward energy. So in an exothermic reaction, heat energy is going out. And what's the opposite of an exothermic? Endothermic reaction. Well, it turns out you can actually write the amount of energy in the chemical equation. Okay? So this is a balanced chemical equation, what we did back there with the hydrogen bubbles. Remember the bubbles? Blue? Okay. So we did the hydrogen bubbles in the back, and every time we burned a mole of methane, 1 mole of methane, that's 6 times 10 to the 23rd atoms of methane, or molecules of methane. Every time we burned 6 times 10 to the 23rd molecules of methane, we produced 888 kilojoules of heat. 888,000 joules of heat. So we can write this as a product. In an exothermic process, energy is written as a product. If you burned 2 moles of methane, you'd basically make 17,000 joules, you'd make 1,700 joule or 1,800 kilojoules of heat. Make sense? If you burned a half a mole, you'd make 444 kilojoules of heat. See how that works? Get the general idea? Have you picked up on the pattern? Cool. Works the same for endothermic. Where would you put the energy in an endothermic process? On the other side, with the reactants. In an endothermic process, energy is placed in the reactants. If you want to decompose water, every mole of water you want to decompose is going to take 285 kilojoules of energy. For every 2 moles of water you want to decompose, it's going to take 571 kilojoules of energy. If you wanted to decompose 4 moles of water, you just double this. If you wanted to decompose 6 moles of water, you triple this. That's how you use energy in endothermic and exothermic processes. Cool? Give me a thumbs up if that idea makes sense to you. Give me a thumbs down if you want to go over it again. Okay, thumbs down. So, in an exothermic process, energy is made, energy is released, so it's written as a product. In an endothermic process, energy is consumed, so it's written as a reactant. And you can use the math to basically look as a ratio that for every 1 of this, you're going to make this. If you use twice as much of this, you'll make twice as much of this. If you are going to produce, based on the ratio of 2 to that, balanced chemical equation, if you want to use up 2 moles of water, it's going to take this much energy. If you want to use up only 1 mole of water, it's going to take half as much energy. So the math works just like a mole ratio. Okay. In the mole ratio, if you wanted to consume 2 moles of methane, you're going to use 4 moles of oxygen, you're going to produce 4 moles of water, and 2 moles of carbon dioxide. Okay. You can just double everything. If you wanted 10 of this, you're going to need 20 of this, you're going to make 20 of this, you're going to make 10 of this, and you're going to make this times 10 amount of energy. That's the mole ratio. Thumbs up for ready to move on. Thumbs down if you want to go over it a third time. Move on. Okay. The activity series. This is the activity series. It's also on the wall. So you might have noticed yesterday, if you were here, that the copper that we put in the silver nitrate, the copper kicked out the silver nitrate, or kicked out the silver out of the silver nitrate. And it did that because copper is right here in the activity series, and silver is right here in the activity series. So copper is more active than silver. Copper will kick silver out. Lithium will kick out anything. Anything you put into a lithium solution into, lithium will kick out that metal. So anything above will kick out anything below.